So, welcome to the showcase of my music maker with the CCT mod in combination with the Advanced Peripherals mod. In this case, also with the Create mod. In the showcase, I will show you how to set up your own organ, go over the UI, what all the setup requires you to do. And after that, I will also go into a little bit of detail of the code. Here I have just a very simple setup that covers one octave that the pipes can cover, split into two different octaves. From beneath, it's basically just a lot of modems that are just connected to the PC itself. When we now just open it up and open up the whole organ thing, we have three sections you can see. We have the organ section that we are on at the moment. We have the pipe section and the connection section. In the organ section, you have this gray box. In here, you can see and select the different organ files that you have created. With the delete and new button corresponding with the file name, you can delete files, create new files. Over here, you will be able to edit the organ files, save them, and also play them. In the pipe section, you see on the right already, this is the config file you will need to edit. There you only need to set up the pipe and the node. The peripherals are already in here. That's why you need to connect the modems to the PC. Now, over here, you will see the pipes. They are currently none in this config file, so there won't be anything. And here, where this black box is now going up and down, you will see the nodes of the corresponding pipe. This box is so you can set the output of the whole organ, because the redstone integrators we use have an output side that we need to specify. You can play selected pipes. You can turn them corresponding on and off. Just like you do the sound, you need to turn it on and off. Here you have just a save button so you can save the config, and you have a create verify button that will create a verification organ file that will play every node and every pipe once, so you can see if everything works. In the connection part of this whole thing, you have a frequency and a max distance. The frequency will be so a pocket phone with a wireless modem can connect to the organ, and the max distance is so you can specify the max distance you can be away with your phone for it to actually work. With the open and close buttons, you open and close the frequency, and this big black box at the bottom here is just the log of what is going on. Now I'll just show you how to set one up when you don't have a pocket phone. I will do this briefly because it is really annoying. So usually you just start and specify pipes at nodes. After you save it, you can see you now have a new pipe with the two nodes. When you now play the pipe, you can see nothing happens. Why is that? Because it's the wrong output side. We go in here, try again, not working. Then we try the left side. The left side works. Right side not working. Front. The front is opening the trapdoors. So now we know what the front side is. And the back side. Okay, we also want to close it back up. So we now know the, I think it was the subsection. No, left. Yeah, now we know left is the correct output for us. This is an issue that's not related right now. Just I will fix it. Okay, now that this is completely fixed, we don't have this anymore. So when you now have this and you play the pipe, you will need the correct goggles so you can see the pitch on those. And we just grab them really quick. So now we see this is on, and this is A sharp and is the big one. That means now here we have an A sharp, and I will save this under the big pipe section. Now when I save this, I can verify it by playing it. It turns off, so it's correct. And I will test, which 2. It is the smaller pipe, and it's a C. So C in small pipe. Okay. But this is just really annoying when this is a rather small one, so it's alright. But when you have a big organ system with note blocks maybe added as well, this will be a real hassle. This is why I have the phone version as well. In here, you have also a connection section and an edit section. The connection will just be for you and your PC. There you can, at the top here, you can input the frequency of your organ, so you can receive and send the stuff. When I do this, I set up my PC. I want the frequency 125 with a MAC distance of 150 blocks. I open this frequency. Now you can see it was 125. When I now say I want to connect to 150, it will not work there. Connection 150 failed. When I now say 125, it will try to connect. Connect to 125 failed. I open the frequency. You should make sure you have a wireless modem installed. All right. Now when we open 125, we didn't wrap it. So now 125 with 150 blocks. Open it. Now it should work when we try to connect to 125. Now we are connected. Now we will receive the config file. So in here, we now have everything listed. Now we don't need to go back here. We can do most of it via this one. And I will just go in here and do like 5 ones. All right. Now I will just go through them. 5. Perfect. Now I will save this whole thing. Now you see we have this in here. We can not play it yet. Why is that? Because the PC, it doesn't know it. The config file is not here yet. That's why we need to send the config file. And now when you see it here, we have the config file in here. That's how this whole system works. Now we can go in and say, pipe. This is A sharp on small. A sharp in the small pipe. Now we can go to 2. 2 is a G sharp in the small pipe. G sharp. Small pipe. Now we can save this whole thing and send it over. Now we can test it. And I want now to play an E. It works. And I now want to play a G sharp. This works as well. So I will now set up the complete rest of this whole thing. And then I will see you again when I have done that. All right, I have now set up the whole organ. You can see here, big pipe and small pipe are completely set up. I will now just send it over and test everything. So, small pipe is C. What I noticed though, we have 2 F sharps. So, now we need to figure out what F sharp corresponds to what. We are in the small pipe. And for this figuring out, I will just do the one simple thing. I just use the PC. So I will just disconnect from 125. And we can see here we got an error. Okay, we'll just run UI again. All right. Like I said, left was the correct output, and we had some problems in our small pipe with 2 F sharps. So this is the first one, and I will just rename one of them. F sharp in the big pipe, small pipe right now, small pipe F sharp 1. Okay, yeah, this makes sense. We have the low note and the high note like that, F sharp 1. And I think this is the only time we have some duplicates. Yes, it is. So now we need to do the same for the big pipe, I suppose. So big pipe, no, that's the other big pipe. Where are you? Here. Now I'll just go in here, test this. Okay, so this is correct as an F sharp. And now we need to go for the big pipe with F sharp 1, save it, and now it's correct. Yeah. Okay. Now that everything is set up correctly, we can go and create a verification file. This will create this whole file. That is not updated yet with the new format. I will just do this really quick. All right, now that everything is set up, we can just play it. Currently, this is one of the biggest issues. I need to do something about this. It plays them completely random for the most part. That is just something I need to fix still. But now you can see we have a verification file. Everything seems to work. We can go now in here and just create a test file. That is now called test. And yeah, in here I will just go quickly over what everything does. So we have single line comments. We have block comments. We have the mute keyword. This will mute everything. We have the mute keyword that can mute a specific node on a pipe, and we have the mute for the whole pipe itself as well. Then we have the play keyword. This will play a node, the same syntax, and it's the same thing. And we have the delay keyword that can take normal integers as well as floating point numbers. This is completely set up in seconds. So like you saw, you can use something like 5 seconds. We would not play it, it would just sound horrendous because there is no mute in the end. That's why I always wanted to have a mute file that can just mute the whole organ when you need to. These are all the keywords that I have supported. The syntax highlighting for block comments does not work because regex won't work, I don't know. Yeah, this is the whole thing. And now I will go over the code, some struggles I had, and can give you a more brief overview over the file system behind the organ itself. For this, I'll just grab me this. And here is already quite a bit going on. So we go to the top, and I will talk about the file system first. As you can see, we have just some Lua files. We have the .org files. Those are the actual files in the end. We have two configuration files, where the .conf file is the Redstone integrator with pipe and node assignment. And we have the setup config, which just holds the output side, so it can be brought up. What we currently see is the ui.lua. This handles basically everything that we do in the UI part. I will go briefly over it because it is not that fancy, not that hard. Something like player or config are a little bit more interesting. Not that hard, but a little bit more interesting than the UI. The UI consists of the Basalt UI, I call it framework now. I use version 1.6, even though 1.7 is still out. That's because I had just some issues, and in 1.6 I didn't have them. Then we just use the player and the config to execute the functions of those, and some helper functions as well. All right. I will skip over these things because it's just some assignments and we go into the config later. So in the beginning, I basically create all the UI elements. It's nothing really fancy, just some basic UI declaration with Basalt. Yeah, when you use something like Visual Studio's thing, not MVVM, like the older one, it looks not the same, but it is basically the same thing. That's just what's going on here. After that, we start with functions and events. In here, I have the fill list, drop-down, load config, and set output side functions. Those do exactly what they do. They fill the list. In this case, they find all the .org files and put them in the file list. The true keyword is just so we reset the selection. After that, I fill a drop-down with configuration content. After that, I load the config file and I just set the output side. It's very self-explanatory. So when something in the file list changes, that's just an extra function. It's not an event. It's just an extra function, so I can call it whenever I want. Those are all those blue functions here, at least in this section. And here we just clear it, check if the item is nil. So when we don't have an item selected, we just return. And why not? We load all the data of this file into the editor field. When we change something in the pipe list, we still again have an item name, and there we have a drop-down name. And then we go to the configuration content and load this stuff corresponding with drop-down pipes. On change, we clear the pipe list. And there we again loop through the config content, do some just some basic if statement stuff, where we just compare stuff and add the corresponding nodes to the list. And then we say we changed the list, so do this event, please. Then list messages, there we can just add a message. This is for the whole modem stuff, so we can add something at whenever we want. Handling the modem is also rather simple. We just repeat until it's open as false. This is a thread separately from everything else. And in here we still have the debug. We don't need this anymore. But yeah, we pull the event from modem message because we want to receive those. Check if the distance is higher than the max distance, and when this is the case, well, we just do nothing. When we get a table, because the config thing is a table with other things in there, and we have a connection, then we check if the method contains play. Because when we play, we need a pipe and the node. Those are corresponding to the indexes here. We select the index, check if the index exists, and then we firstly list that the index is not found, or that we play the index, and then we play the index. Oregon, I will give you an overview over that later. Then the send statement is when we receive sending, then we want to rewrite the config file. So the receive file is in this case in message at block 2, because in block 1 we have the keyword for send. Other than that, we just loop through all the lines and write those. And then we need to reload everything. In the connect statement, we set the connected frequency to a reply channel. The reply channel is the frequency that is selected on the phone. Under modem transmit, we then just transmit that we are now connected to our organ, and then we add the same thing to our view. When you disconnect, we just remove the connected frequency and say we're disconnected. When we receive, this is now when we receive a config file. So when we want to receive a config file, we only want to open the config file in the read mode. We want to get all the lines, and then we want to transmit all the lines. That's basically it. Now, even more basic stuff is just like something, the menu bar is just something like, well, you have an ID. When I click now on the next entry, hide the first one, select the next one. File list, well, we just call the file list function. New click, well, we create a new file. Most of those are not that exciting to look at. So when you want to see what the other on-click events or other stuff are doing, then, well, you can look at those in the GitHub. Now what we have is a lot of config stuff. So we will look at the config file first. After that, we will look at the player file. In the config file, let me get this. We have first a function that gets used a little bit more in this file. That's get chart to end. In this function, we just get from a character to the end and return this. Now we call the check function because it checks if the config file exists. And when the config file does not exist, we want to create it. So we go in here. We firstly open the config file, and after that we go in and need to have all the peripheral names. This is why we need to connect the modems. So we have all the peripherals and can get them by name. So that we check if it's a Redstone integrator, because when we don't have a Redstone integrator, you can't send a Redstone message to it. And then we use the current format with peripheral name, pipe name node, where the %s characters represent strings. So first we have the value. This is just the name of the peripheral. And after that, we basically just say use this character or this character. And this is like nothing. And then we close the file. When the config file exists, we can load it in 3 different ways. We can do nothing, and this is will return the set functions. We can output the whole config content, and we can return the get functions. Config content is just the objects that contain the peripheral name, the peripheral, the pipe, and the node correspondingly. So when we want to create an object, we loop through everything until we don't encounter a line anymore. When we find the opening bracket, we say, well, create object is true because now we are creating an object. The objects contain a peripheral, a node, a pipe, and a name. When we find a closing bracket, we say, all right, put the current object in the next available position for the config content overall. And then we clear everything and say we aren't creating anymore. When we now find the peripheral name, we get the name by getting the charge to end, wrapping the peripheral in there and setting the name. The same thing with pipe. When we now passed in a 1, we would return just this table of config contents, but will contain this form of table. Now we have an output table as well. This occurs when we pass in nothing or 2. So we go all through the config content, check, get an index based on the pipe and the node. And now we do the following. We have an index now. We check if this index exists. It does not exist. When the index is not existing, we add the set or the get function correspondingly. And in the end, returned. And this is all the magic behind the configuration thing. It's basically my own little file parser. It's not fancy at all, but it does the job. When we now go to the player, there we have a play function and the create verification function. In here, I want to add this keyword when we are added. So in here, when we want to play a file, we have a file path, we have an organ that we pass in. These are the set functions, and we have a site we want to output to. First, we open the file. We say command block is false, and we set the sleep method. This is for sleep purposes. I will get to this after the code. Okay, now we do the same thing with reading with a while true. We just go through everything until we don't have a line anymore. And now in here, we firstly check for command blocks, because when we have a command block, we don't want to do anything until we close it again. And that's why when we find in this line 2 slashes or command block is true, then we do nothing. This also means in our org files, we can't do something like this, because we only check with else ifs. This means I would need to create different if statement for this here, but I don't really want to do that. It's just the way it is. It still works, So yeah. In here, I switched from the find stuff we have up here to regex because it's a little more specific and works a little bit nicer. So when we match this regex expression, that's just delay with any white space with any digit, any amount of digits, and then 0 or 1 points, characters, and then again digits. Then we set the delay to match this. When we have a match, it returns the whole string. After that, we want to find delay because we get indexes. From there, we can just substring it. So we only get the time, and then we have a delay time. Regex is because this is important because when you have something like delay HB2, it would not match anymore because it does not satisfy this regex statement. So you can't get into errors there. Then mute. Well, we match against 3 different regex stuff. First against this. This is just mute and then the node host stuff. After that, we mute pipes and then just mute. Then, yeah, well, then we have an output that we have set. Now we need to check if it's not nil, because this can happen. Or at least in this case, it can happen. Because when nothing matches, this is nil, so we don't want to do anything. And yeah, in here we then find node, because we are now matching this regex basically. And now we basically get the node keyword and the pipe keyword, get the node and the pipe, create an index, and set this side to false. We do the same for pipe. We check here, set the index, get the pipe name, and now we need to loop through everything once and compare the key with the length so that we have an identical match, because when you have something like test, and you have something like test, and you have something like test2, and you search for test, both return true because test is in both of them. So we need to compare the length as well. And then when nothing matches, well, we only have this left. So we loop through everything and mute it. In the play section, it's basically the same thing as the mute section, just with the difference, well, we use the side and set it to true. That is the difference to the mute section. We just reverse it. Now in the end, creating a verification file, well, we open the file name, in this case, verify.org. We write it, we say that it's auto-generated, and then reuse this pattern to write it into the file. The .2f is for 2-point precision and the floating point number. And then we use the delay, the node, and the pipe, and write those in here, here, and there. After that, we need to write one last delay and mute, and then we can close this file. But this is not all, because we still have the phone. The phone is also not that fancy, but it exists. This is just one file. Really simple, 2 files in general, but yeah. And here we still have a frequency. This is just the frequency of every phone. This can't be changed. And we have a connected frequency that we can use, and is connected. Then we again set all the UI elements and have now again the basic functions. In here I have predefined the whole helper functions just in this file because I was lazy. I didn't want to use an extra file for the phone. And it's basically the exact same thing as in the other section. It's the same thing. The only other part that is here interesting is like when we're not connected, we check if we can connect, we connect, and then we transmit stuff. Of all this is all basic stuff. We transmit, disconnect, we close the modem, and disconnect and print it. When we want to receive, we need to redo everything again. In here we have position 5, this is the message, and then we have 3 tables we get back: the config, content, the get, and the set functions. We get a config file, content, and output side back, and then we reset everything, and then we say received. And when we time out, we say we didn't receive. And when we send, we create just a table with the keyword send, the lines, and the output side, and send it. And yeah, in play a pipe, we just set play with the corresponding stuff. It is really simple stuff, but it was quite a while until I got it running. Because having only one PC manage everything makes things slow. Before that, I had multiple PCs. So you would have this PC managing everything, and it would just broadcast one thing, and then you had one PC per node that can manage everything on their own. Horrendously stupid, because it just fills up so badly. So now I just have this one PC that's connected with modems. A lot simpler, doesn't require a ton of PCs to function, and should be quite a bit cheaper. And the biggest challenge I had was in the player section, because when you loop through every single pipe there is, it can get slow. Because the first iteration that looked like this at all, it was, especially for the organ, it was an organ table that had the index as the pipe, another index as the node, and in there, now we can have access to the peripheral. And now from the peripheral, we can say peripheral dot set output and say peripheral dot get output. That's how it worked in the beginning. Really stupid, really slow. We have 2 lookups, one here and one there. After that, we have another equals lookup for the function itself. After that, I simplified it. I said, I don't need this lookup. I can just use this and shorten it to one lookup and then have the peripheral itself there. Then I learned, well, you don't need to have this. You can assign functions. Well, replace this peripheral just with pointer to this, and then later on do the same thing for this. And now we have the functions directly with one index lookup. This made everything in the end work really nicely and really fast. This makes something like this possible. This can get loud. It's just it now flickers everything here on and off as fast as it can. Yeah, you can also see not everything turns on and off because, well, those here point at the wrong thing. So yeah, they don't turn on, but overall, it's nice. So it's fast. This is a really big reason that everything is so nicely. Same with mute. I needed to find a way to mute faster because muting did slow things down. And now it's, I don't know why, but it's now fast enough that I actually need a sleep 0 to have just a really short sleep, so you can do stuff like when I now use, I create a test. Here's it. When I now mute, delay 0.5, and now I say play node 1, node G, small pipe, and then I say mute node G pipe, small pipe. Save this and I play it. Ah, not anymore. Okay. Yeah, now you could hear it. It is a really short pulse. But now I need to do an extra 0 delay for it. It just turns on and off really fast. So you could still flimmer, it would just require an extra delay stuff in here. And yeah, this flimmer stuff would just to stress test basically how many nodes it can handle at the same time. And you can turn on and off at least 12 nodes at the same time. Another thing, chord blocks and like comment blocks. You can have multiple lines of them, but that means we need to skip stuff when we are still in a comment block. This results in performance loss when the comment block gets too big. I noticed performance loss at around 100,000 lines in one comment block. So I would say you are completely good to go with around 50,000 lines. When you want to play it completely safe, don't make a comment block longer than 25,000 lines. But I don't think anyone would ever do this. So yeah. Comment blocks are really nice when you want to like mute and have delay 0.5. And when you want to test sections, you can have now this section commented off. And now you can have, I don't know, play a pipe, big pipe in here, and it will just do this without any of that. So when I would actually say that play pipe, small pipe, it would not execute this. Yeah. It just as simple as that. Yeah. And this basically was everything. It was hell of a journey, quite a big break. I went from the first 3 versions of this was just with multiple PCs and making this as neat as possible, and then basically just dropping it because it was painful. I wanted to swap over to this a lot earlier, but I didn't because I didn't have the motivation. I now came back, I would say around a week ago, and I started this project again, revived it, worked on it quite a bit actually, and now I have this whole thing working. It's actually really neat. It works really nice. There are still a few things I want to add. Something I just noticed for a second. When you create a new file, I want to already have the pipes configured with test and 1, 2, 3, 4, 5, and so on. This just is because you could instantly play notes. You wouldn't first need to write in a pipe and a note and then play it. You could instantly play it and then, yeah, have it work, I guess. Something that could work as well, I didn't test it so far. When we go to big pipe A sharp and we just do something like this, we create a new thing. You say now peripheral name is now redstone integrator 50. Pipe is now chord A, and the node is equal to chord. We don't really need the node, but chord 1 essay now, and then we do the same thing again with big pipe D. Big pipe D. We say now peripheral name is equal to redstone integrator underscore 51. Say the pipe is now chord A, and the node is equal to chord 2. And when we save this, we now have chord A, which contains those two nodes. And when we, now go in the organ, and I will reuse the test file again. And we now say play, we first want to mute, play pipe chord A. I think that's what I named correctly, yes. And then I say delay 1 and then I mute again. You can reset redstone integrators, and with correct pipe assignment, you have now chords. And you can just access. So some stuff like this is possible. You need to be smart with the config file. You need to edit it a bit more. Another thing I still want to add is code highlighting for the config file, because currently it's a pain to look at. Let's be just real. It's a pain. Having no visual differences at all is painful as fuck. I want to go in here and highlight pipe and node, as well as the perfect name in here, so you have a little bit more visual, a little bit more nice. Yeah, this is basically, so my last steps I will probably take in this project, make maybe a few adjustments still, but yeah, this was everything. This was a hell journey to get here. I'm really glad it's done. It was a lot of fun to do in the end. Just need to get the motivation back. And yeah, when you enjoy what you saw in the beginning, I will probably put a little demo there with a probably bigger organ. And you want to use it as well, I may look into creating an installation Lua file that you can just get, so it installs it for you on your computer curve PC. When I won't do that, well, you either way need to go to the GitHub when you want to use it. I will update the GitHub probably in a bit with all the end files all on a disk, so you can have a disk that is just up and running, so you can copy and stuff. Yeah, that's basically it. I hope you enjoyed. When you watch everything like what the fuck, it's probably quite a bit of a video, because I, never did anything like this at all. But yeah, that was my music maker.